Hey folks, and welcome to the latest video in the SAM for IBM Rhapsody series. I'm Andy Lapping, and in this video I'll talk about a really cool feature of SAM, toolchains. Now, two of the biggest hurdles to applying AI to model-based engineering are the context window and its non-deterministic nature. Now, we can mitigate against both of those by introducing automations, as we've seen in previous videos. The problem is someone has to create those automations, which means setting up Eclipse, learning Java and the Rhapsody API, loading the plugins into Rhapsody, and so on. At least until now. Toolchains are a way to visually design automation helpers by sequencing the MCP tools provided by SAM. SAM provides the AI with the option of executing those toolchains in either broker mode or plan mode. Plan mode returns only the toolchain specification, so the list of tools in order along with their parameters, introducing determinism. The AI can then run each tool in order. Broker mode, on the other hand, will execute the entire toolchain and return only the final result to the AI, so deterministic behavior and a drastic reduction in token usage. Let's see an example before we see how to design toolchains. Here in Rhapsody, I have a class selected in the browser, and in my AI client, in this case Claude, I'll ask it to apply the dynamic singleton design pattern to the currently selected class. Now, that design pattern involves a number of steps, such as adding a private constructor, a static instance attribute, and a custom accessor function. Claude first checks if there are any toolchains available, so it doesn't have to perform every step itself. And it does indeed find a toolchain that applies that specific pattern, so it asks SAM to execute it. As we can see in the final result, it took 25 steps to implement that pattern, but Claude didn't have to invoke those steps, and it sees only the final result. Without the toolchain, Claude would have had to make many more MCP calls, consuming many more tokens. In the model, the pattern has been applied. And we would see the exact same result every single time the AI invoked that toolchain, because it is deterministic. Let's see what that chain looks like, and then we'll design one. Now, this model contains a bunch of sample toolchains, including the dynamic singleton. Let's right-click that one and select SAM Open Toolchain Designer. Now, the designer is web-based, and it can be opened in Rhapsody's own internal browser or in any external web browser. Here I'm using Rhapsody's. Now, we can see here a combination of tool nodes and flow control nodes. For example, the first node here is the getSelectedElement tool. Then the chain tests that selected element, make sure it's a class before continuing. The green boxes here are groups of nodes. The chain has to create an instance attribute, a static getter function, a private constructor, and an overloaded operator equals. Now, if I double-click one of those, then we can drill down into it and we can see the MCP tools being used in that group. Adding an attribute, setting it to private, switching off its accessor and mutator through properties, and so on. Now, whilst designing chains, we can debug them by executing them. For example, I'll select another class in Rhapsody, and then back in the designer, I'll expand the execution tab, where I can run the chain, I can single step through it, I can set breakpoints and so on. I'll click Step. Now that runs the first tool in the chain, getSelectedElement. In the execution panel, I can see the exact same data that the AI would see if it invoked that same tool. I can then step through the toolchain or simply let it run to completion. Now let's design a small toolchain just to show you how easy it is. I'll start by creating a new toolchain model element in the browser, and then I'll launch the toolchain designer on that new chain. Now, the palette shows all of the available SAM tools, and there are a lot of them. So the easiest way to find one is to type into the filter field at the top. Let's drag the getSelectedElement tool onto the canvas. Now let's keep this chain simple. let's find the set description tool. And once again, I'll drag that onto the canvas, and then I'll wire the first tool to the second. Now, if we look at the features for that set description tool, it has two parameters: the GUID of the model element that needs a description, and then the description itself. Now, those would typically, of course, be supplied by the AI. But in this case, the GUID parameter has been automatically set to the previous node in the chain, the selected element. But it could be any prior node. These connections only indicate tool sequencing, not necessarily data flow. For now, let's hard code the actual description to hello. Now we can run it. I'll select this package in Rhapsody, and then back in the designer, I'll use the execution panel to execute it. And there, that model element now has that hello description. Now, tools can be parameterized, so the AI can provide input to them rather than simply being black boxes. Let's change that description from being hard-coded to requiring user input, and we'll give that a label. When we run it in the designer, we now have a field for that description. Let's type something into that, and then we'll run it again. Now, of course, the AI would also know it needs to supply some value for that field. In addition to the designer, SAM also provides a toolchain runner. Now, that allows users of Rhapsody to invoke toolchains, making it easy to design simple automations and make them available to your users with no AI required. Here on the toolbar, I can open up the toolchain runner, which opens as a sidebar in Rhapsody. It's a web page, so again, you could launch that as in an external web browser. Now, this lists all of the currently available toolchains. If I select one, I can see its description here, so I know what it does. Let's select the one that we just created. Now, there is the parameter that we added. Let's type something into that, and then we will run it. So that's it. If you're using AI, toolchains can introduce determinism and drastically reduce token usage. Even if you're not using AI, toolchains allow you to visually design and execute Rhapsody helpers without writing any code. Well, that's it for this video. Over the course of the series, we'll explore other use cases and capabilities of SAM for IBM Rhapsody. But for now, thanks for watching.